Ghost launched January 15th atop a SpaceX Falcon 9 rocket. The ship had landed on the Moon March 2nd, 2025. Blue Ghost also plans to capture high-definition imagery of a total eclipse as the Earth blocks the Sun just before a lunar sunset ushers in frigid lunar night March 14th. Intuitive Machines sent yet another lunar landing mission IM-2 of its own that was launched as February 26th and failed to land on the Moon properly March 7th, 2025. Actually, it seems that the landing was much harder than the 1 year earlier of its predecessor, IM-1. From the IM-2 velocity graphs I've prepared for the final minutes of landing, we can deduce that the IM-2 bounced 3 times before final landing, and then finally glided through at least 21 sharp random walking steps, the first half of which are shown here. We can only guess what would have happened if the fuel load had been much greater. Due to problems with the laser rangefinder, Intuitive Machines reported disruptions in its operation, which occurred even before the landing maneuver. We can ignore its readings and limit ourselves in the final phase to the only, fairly reliable, readings concerning the speed relative to the surface. However, even here, a few strange jumps should be noted. 3 minutes and 28 seconds before the expected landing, the reading jumps in a fraction of a second by over 100 km per hour, from 1,355 to 950. This is repeated 3 minutes and 13 seconds before the alleged landing. This time, the speed drops by as much as 122 km per hour, from 942 to 820. This is repeated for another 2 minutes and 59 seconds before contact with the surface. This time, the jump is only 45 km per hour, from 824 to 679. From that moment on, the speed, instead of decreasing, begins to increase to 835 km per hour for 1 minute and 50 seconds before the alleged landing.
Approach 12 minutes into PDI.
Again, the engine will continue to fire, albeit it will continue throttling down as we approach the lunar surface. And a reminder, the VIS is a simulation based on flight data, but if we do lose contact with the lander, which can be expected based on the conditions at the lunar south pole, we will continue to see projected data on this visualization.
And we're approaching G, as in ground, to 2 minutes. We expect to drop this clock here in 2 minutes and take all of our commands.
The operator notices that something strange is happening and switches the clock to the full duration of the mission. Here we have the 7th day, 17th hour, 10th minute and 11th second of the mission. The speed is 837 km per hour and still increasing. This means that the ship is falling with perhaps significant undefined lateral thrust from the main engine. The speed increases in this way for the next 28 seconds until it reaches 940 km per hour, which arouses the fully understandable consternation of the Polish commentator reporting the event live. At the same moment, the speed suddenly drops to 25 km per hour. It seems that Athena hit the surface at the enormous cruising speed of a Boeing passenger plane, losing most of its speed, and began to glide at the speed of a cyclist, tearing through the mounds of dust piled up in front of it. Still on engine thrust, Intuitive Machines declared that the pressure in the combustion chamber remained for a long time after such a landing, so that the speed increased by 4 km per hour. Only to drop again to about 25, and then with a sudden jerk by another 15, and 2 seconds later it practically got stuck to 0. Or rather the pace of a walking pedestrian, 4 km per hour, and now it was just beginning. On average, every 10 seconds, the working engine accelerated the Athena rocket, probably sliding on the surface in a sideways position, from this walking speed to the speed of a car moving in a built-up area. Trying not to break traffic regulations by more than an additional 20 kilometers per hour, once it reached a maximum speed of almost 70 kilometers per hour. This happened for about 21 cycles, before intuitive machines decided to take the fragmentary telemetry data it had treated us to so far off the screen. Each time, the ship accelerated to this maximum speed of 50 or more kilometers per hour, and probably after hitting another boulder it lost its speed to almost zero. Throwing the obstacle aside and again gaining speed from close to zero to the maximum urban speed. It could look like a particle moving in Brownian motion. It certainly did not bounce off the surface as in the visible animation, because in that case its speed would have a shape close to a sine wave, and not a sine wave that was bent to zero at each maximum. The spectacle must have been magnificent and lasted until the fuel was exhausted.
And we are currently not seeing our quasonics. So we are in quasonics LOS.
Alright, that's a
See our
quasonics.
signal strong on the spectrum for Talos. I'm not seeing our quasonics on our spectrum as of yet.
FM, what mode are we in?
We approach 17 is the last we've seen.
Alright, so that's up on one radio, and they do have a loss of signal in the second.
Fido, I'm looking at the SenseXL. Do you see the SenseXL reading?
Let me look.
That's the mission director detecting, see if
I
the
am
lander...
seeing he sensed Excel 1G.
So that was the mission director, Tim Crane, trying to figure out what is the vehicle sensing. It has two inertial measurement units on board. You can think of those as your inner ear. So when he's asking what is the sensed acceleration, that's what he's asking for, is what is that inertial measurement unit, that inner ear, detecting as far as acceleration.
Again, as we've mentioned, the viz here is just an interpretation of landing.
Yeah, let's go ahead and stay on Nova control. Looks like the viz is hovering. We can't...
Prop, what are you seeing on the engine?
The engine is still in idle at min thrust. We are still seeing chamber pressure.
So we're getting good data. We heard that we have one radio up, one radio loss of signal. We just heard that we
I'm
have...
seeing guidance to solution for time to go as increasing, just indicating to me that it is the onboard nav state is not decreasing in altitude.
The good news, the HRN laser is now ready to fire.
So we heard that we have one good radio sending down data, one that has loss of signal. We have prop...
Standing by with a manual command for landed ops.
Yep.
No recommendation at this time.
Yep, we have prop telling us that we have good data. That was someone just commanding. We heard exec mode to go into this firing mode, and someone standing by to get into our landed ops mode. I'll wait for Dr. Crane to confirm here. But if we're pulling down data, we'll see how this goes. Looks like Tim's about ready to jump on the loop and sort out what we saw on the viz versus what the folks inside of Mission Control are seeing on their monitors. It's a good reminder, too, this public channel that we're listening to here in the studio, Leah, and what people are listening to at home, at the landing party at Lone Star Flight Museum.
All right, folks. I'm showing that we are sensing lunar acceleration. So we're on the surface. Let's evaluate.
All right, let's continue to evaluate. I hear we do have a picture from a portion of the descent. Is that right over there? All right, so that's a picture during braking, about 10 kilometers up
MD,
from
this
the
is
lunar
Prop on
surface
IM-1.
that we do have while we wait
We
for a
can
little more
confirm the
information.
engine is still running. and therefore needs to be upright. If we were in a different configuration, the engine would have snuffed.
Okay, so we have confirmation, I believe that was from Khan, that says the engine's still running. This picture you're looking at, the 10 kilometers up during that braking burn, that powered descent initiation, that long burn that brought us 4,000 miles per hour braking burn. Incredible shot.
Yeah, that's
there.
what I'm saying as well.
All right, there's another view there. Looks like from this panel we're looking at the garage, so that's Lunar Outpost Map Rover inside of that square right there, Leah. And this looks like it's probably about the same altitude, maybe about 10 meters above the surface. And one more here for everyone. It's about the same altitude there, maybe a little bit more exposure, but these
Camera's still running in HRN mode.
These photos came down for us just a few moments ago. Wanted to share those before we jump back into mission control as flight controllers are looking at this dynamic situation and learning.
Yeah, go ahead and put us in landed ops. It looks like we're down. We need to evaluate that situation, and I'd like to get a picture.
As they say, picture didn't happen.
Hello,
so Dr. Crane's onto it right there. A couple things here, Leah.
FM3402 was acknowledged. AOS on Thales.
What we're hearing in our ears and what folks at home are listening to are not the
Mode
only
20 landed
channels
ops. Check your systems.
that mission
Engine
controllers are working on. It's an engine shutdown notice. We'll see what comes out of this. But they're all on different loops having separate conversations, so all the information that we have, that folks have at home, isn't necessarily the exact vibe inside the room. So we'll stand by and listen in to see what we have here. I did hear Dr. Crane call out that they are getting readings for lunar
Folks are moving to the
acceleration.
post-landing court procedure.
All right, Spark, I'm going to start shutting some stuff off as soon as we can.
Copy. Can you meet me on my loop, please?
Feed lines are inerting.
All right, so if we have enough data to be inerting feed lines, that means the engine's no longer running, and it's a state to bleed off that extra pressure. This is part of that safing bit that we talked about earlier, Leah. Looks like our CEO, Steve Altimus, just stepped into the room. That's in the bottom right hand of the box here, talking to the mission director, Dr. Tim Crane. He just called out telling Spark to turn some things off. That's because we need to remain in a power positive state, Leah. Getting that top deck solar array into a spot where we are able to charge, but sometimes you have to turn a few things off to make sure that you're charging and not just burning through that power. All right, by my countdown clock, it's been about 22 minutes since we started that PDI, Leah.
And again, we were anticipating landing at about 11:31 a.m. Central Time, 12:31 p.m. Eastern Time. It can get tricky with communications on the lander when you're in a...
Prop, do we have insight to tank pressure if we turn off the Mogies and the Iggies?
We would, yeah.
All right, that's code for the...
If you turn off Mogies, then we cannot inert or vent the tanks.
Yeah.
We can bring them back up though, right?
Yes,
How are my pressures?
they're low at this time.
Okay, turn off the Mogies and the Iggies.
Going.
Could we turn everything off except the vent valves?
Yes.
That would be everything except MV103 and MV303.
All right, all this activity is regarding the lander's propulsion system. They're going through deciding on how to vent it. We heard two things there, Leah. We heard Mogies and Iggies. That's our motor engine gimbal system, right? And our Iggies are igniter. So they're working through the process of safing this engine. At the top of the show, we talked about the priorities after touchdown, and being safe was first, followed by pulling down some health status information, and then images. And then just about 3 minutes ago, we heard Dr. Crane go ahead and say,
FM3403 acknowledged.
we'll prioritize images. It's just about 9 minutes after the expected landing. So let's hang tight and continue to watch this problem and challenges unfold inside of mission control. Each one going through, finding this challenge, each one getting solved here. It sounds like they're still working through venting the engine system.
So let's power off the Quasonics until we get a handle on what antenna we're going to pipe it through.
Copy. Quasonics is currently in idle mode.
Good enough, thank you.
Quasonics, that's our radio. There's 2 radio systems on the lander. It sounds like when we talk about that vehicle health status, we heard some things for prop. Vehicle health status includes being in a power positive state.
Spark 636 acknowledged.
So we are communicating, commanding the lander, and getting acknowledgments back that the lander is behaving as expected. So putting those things together while we wait for confirmation from Dr. Crane. We have an engine that is shut down. We are venting the engine.
Spark 637 acknowledged.
We are getting acknowledged commands from the lander. Standing by for confirmation from Dr. Crane.
And just a recap of some of the timelines so far today, we had power descent initiation start about 25 minutes ago.
FM3406 acknowledged.
Power descent initiation is the braking burn that really committed us to coming down to our landing site today. We were targeting landing at about 11:30 a.m. Central Time, so about 10 minutes ago now. Again, still just standing by for some confirmation from the teams in Nova Control and hopefully a picture that shows the status of Athena on the lunar surface. Landing site today is Mons Mouton. It is the furthest south target for any landing up into this point.
And pretty credible images we just went through. You know, for those to come down during
Spark 638 acknowledged.
During that landing sequence, showing during that deceleration burn, just about 10 meters, I believe that was, over the surface for those images. See who we have in there. Yep, down towards the bottom right-hand side.
Spark 639 acknowledged.
Of your screen, we keep hearing those acknowledgments of the vehicle receiving our commands as we stand by for the real deciding factor here. Never a dull moment, Leah.
We did hear that they were going into
Spark 640 acknowledged.
Commanded landed ops. So can you walk us through some of what that means? I know that includes safing the engine as well.
Right, so there's different modes that we need to command, right? At the beginning of PDI, we hear the command for exec mode, all right?
Spark 641 acknowledged.
That's executing the burn maneuver, right? When we switch over into landed ops, it's a different setting on the lander in order for us to go through those steps, safing the vehicle first and foremost, that liquid methane, liquid oxygen engine.
Yep, bring it down. Also, FM, I'd like a recommendation on whether or not we keep Talos 1 up or if we bring it down.
It's going to be a decision on up and down for radios based on
bring it down
power.
for now. We're taking the same pictures.
I would not recommend powering down Talos.
He did say pictures.
He did say pictures, yes. So, hoping to see the status of Athena on the lunar surface soon. We were initially expecting pictures would take a couple of hours to come down as the flight teams prioritized downloading data and safing the vehicle, but this will help us better understand the configuration of the lander.
Spark 642 acknowledged.
Every time we hear Michaela come on the tunes
Order,
there,
can you zoom in on this view? Actually, give me the spacecraft view.
Spark 644 acknowledged.
getting all these acknowledgments coming through.
No, take task down.
All right, we're going to see here. Looks like Tim's
Star
got a good
tracker's
spot.
down.
Keep powering down things that we're not using anymore. Mission director looks like he's looking up at the screen. Maybe they're looking at a little bit of data that we do not have in front of us. Still standing by for confirmation. But we've heard a few steps go through the process, venting the lander system, hopefully pulling down data inside of mission control, confirming Athena's status on the surface. And then finally, it sounds like we've heard a couple mentions of pictures. We've shown a couple from that descent stage. And we're just going to keep standing by, looking into Nova Control here in Houston, Texas, just down the street from Johnson Space Center, to find out the situation inside of the IM-2 mission with Athena's touchdown. Again, that was about, nominally, the touchdown time is about 14
Spark
and a half
645
minutes ago.
acknowledged.
Still in contact with the vehicle right now. We know the vehicle has shut down. Its engines are powered down. We are getting acknowledgement transmissions to the vehicle.
All right, team. Keep working the problem. We're shedding power as fast as we can to keep the vehicle in good health. We are generating power. We are communicating through our telemetry radio, and we are working to evaluate exactly what our orientation is on the surface.
Spark 646 acknowledged. Spark 648 acknowledged.
'21st century uncrewed soft landings and attempts started from Chang'e 3, China, on the 14th of December 2013 at 13:12 Coordinated Universal Time. Chang'e 3 soft landed a U-2 rover on the Moon. This was China's first soft landing on another celestial body and world's first lunar soft landing since Lunar 24 on the 22nd of August 1976. 80. The mission was launched on the 1st of December 2013. After successful landing, the lander released the U-2 rover, which moved 114 meters before being immobilized due to system malfunction. But the rover was still operational until July 2016. Chang'e 4, China, Chang'e 4 lander on the surface of far side of the Moon. Chinese Chang'e 4 lander on the surface of far side of the Moon U-2 rover deployed by Chang'e 4 lander. On the 3rd of January 2019 at 2:26 Coordinated Universal Time, Chang'e 4 became the first spacecraft to land on the far side of the Moon. Chang'e 4 was originally designed as the backup of Chang'e 3. It was later adjusted as a mission to the far side of the Moon after the success of Chang'e 3, after making a successful landing within Von Kármán crater. The Chang'e 4 lander deployed the 140-kilogram U-2 rover and began humans' first close exploration of the far side of the Moon. Because the Moon blocks the communications between far side and Earth, a relay satellite, Quikiao, was launched to the Earth-Moon L2 Lagrangian point a few months prior to the landing to enable communications. U-2, the second lunar rover from China, was equipped with panoramic camera, lunar penetrating radar, visible and near-infrared imaging spectrometer and advanced small analyzer for neutrals. As of July 2022, it has survived more than 1,000 days on the lunar surface and is still driving with cumulative travel distance of over 1,200 meters. Bereshit, Israel, Space IL. On the 22nd of February 2019, Israeli private space agency Space IL launched their spacecraft Bereshit on a Falcon 9 from Cape Canaveral, Florida, with the intention of achieving a soft landing. Space IL lost contact with the spacecraft during final descent on the 11th of April 2019, and it crashed as a result of a main engine failure. The mission was the first Israeli and the first privately funded lunar landing attempt. Despite the failure, the mission represents the closest a private entity has come to a soft lunar landing. Space IL was originally conceived in 2011 as a venture to pursue the Google Lunar X Prize. The Bereshit lunar lander's target landing destination was within Mare Serenitatis, a vast volcanic basin on the Moon's northern near side.
It's hard to hide the disappointment. Well-wishers had gathered to watch an Israeli spacecraft attempt a moon landing. But moments before, Bereshit, or Genesis in Hebrew, crashed just 10 kilometers before touchdown. In attendance at the event, Prime Minister Benjamin Netanyahu, who offered words of encouragement despite the circumstances.
If at first you don't succeed, you try again.
We will do it another time. We reached the moon, but next time we need to have a softer landing.
Chang'e 5, China, the Chang'e 5 returner carrying lunar sample was transported back to CAST. On the 6th of December 2020 at 21:42 Coordinated Universal Time, Chang'e 5 landed and collected the first lunar soil samples in over 40 years, and then returned the samples to Earth. The 8.2T stack, consisting of lander, ascender, orbiter and returner, was launched to lunar orbit by a Long March 5 rocket on the 24th of November. The lander-ascender combination was separated with the orbiter and returner before landing near Mons Mouton in Oceanus Procellarum. The ascender was later launched back to lunar orbit, carrying samples collected by the lander, and completed the first ever robotic rendezvous and docking in lunar orbit. The sample container was then transferred to the returner, which successfully landed on Inner Mongolia on the 16th of December 2020, completing China's first extraterrestrial sample return mission.
Russia says its Luna 25 lunar lander has crashed into the moon. Luna 25, Russia's first moon mission in 47 years, was the vanguard of a planned series of lunar probes. Russia's first moon lander in 47 years has crashed into the lunar surface, the country's space agency reported on Sunday, August 20th. The Luna 25 lander, which Russia had hoped would land at the south pole of the moon as early as Monday, August 21st, crashed into the moon after an orbital maneuver went wrong yesterday, August 19th, officials with Russia's Roscosmos space agency said. At about 14:57 Moscow time on August 19th, communication with the Luna 25 spacecraft was interrupted, Roscosmos wrote in an update on Telegram today. The measures taken on August 19th and 20 to search for the device and get into contact with it did not produce any results. A preliminary analysis suggests that the wayward orbital maneuver sent Luna 25 into an unexpected trajectory, one in which the moon lander ceased to exist as a result of a collision with the lunar surface, Roscosmos wrote. Luna 25 was hoped to be a major space milestone for Russia. The last moon probe from the country was Luna 24 in 1976, when Russia was still part of the Soviet Union. That probe landed in the moon's Sea of Crises, Mare Crisium, and ferried a sample back to Earth, a few years after the last human moon landing by NASA in 1972. The spacecraft's primary landing zone was a region called Boguslavsky Crater, but there were two backup landing spots also available, southwest of Manzini Crater and south of Pentland A Crater. Luna 25 launched on August 10th and sent its first in-space photos back to Earth on August 13th, including selfies with the moon and Earth in the background. The mission swiftly reached lunar orbit, a milestone that Roscosmos announced on August 16th. The loss of Luna 25 could be a major blow to Russia's plans to fly a series of moon missions and its effort to develop a permanent crude based on the moon with China.
The Russian Space Agency stated on August 20th that after the Luna 25 probe experienced a mechanical failure during its transition into the flight path before the moon landing, it lost contact at 11:57 and collided with the lunar surface, declaring the mission aborted. The Luna 25 spacecraft crashed into the lunar surface on the 19th of August 2023.
ISRO, in its mission plan of following the incremental trajectory approach, carried a total of 5 earthbound maneuvers. The fifth apogee-raising maneuver, which took place on the 25th of July, placed the spacecraft in an orbit of 250 by 1,27,000 kilometers. At the early hours of 1st August, the translunar injection was carried out, after which the composite module began the final leg of its long journey of nearly 3,84,000 kilometers for its rendezvous with the moon.
Chandrayaan-3, India, Vikram lander of Chandrayaan-3 near lunar South Pole. India's National Space Agency ISRO launched Chandrayaan-3 on the 14th of July 2023. Chandrayaan-3 consists of an indigenous lander module, LM, propulsion module, PM, and the Pragyan rover. The lander with the rover successfully landed near the lunar South Pole at 18:04 IST on the 23rd of August 2023.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
People are applauding. Let us all wait to hear from the Secretary Department of Space and Chairman ISRO, Shri S. Somnath.
लैंडर मॉड्यूल पूरी तरह से सेफली और सॉफ्टली चंद्रमा की सतह पे लैंड हो चुका है। ये हम लोगों के लिए बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूर के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर के।
बहुत ही उम्दा। The hard work of the entire ISRO community has come to fruition.
आदरणीय प्रधानमंत्री जी, नमस्कार. Sir, we have achieved soft landing on the moon. India is on the moon. Sir, I request our Honorable Prime Minister to address us and bless us. Thank you, sir.
मेरे प्यारे परिवारजनों, India is now on the moon. Friends, on this joyous occasion, I would like to address all the people of the world, the people of every country and region. India's successful moon mission is not just India's alone. This is a year in which the world is witnessing India's G20 presidency. Our approach of one Earth, one family, one future is resonating across the globe. This human-centric approach that we present and that we represent has been welcomed universally. Our moon mission is also based on the same human-centric approach. Therefore, this success belongs to all of humanity, and it will help moon missions by other countries in the future. I am confident that all countries in the world, including those from the global south, are capable of achieving such feats. We can all aspire for the moon and
Even
beyond.
The 24th lunar lander of another private company, Astrobotic Technology, suffered a propulsion system leak on its way to the moon shortly after it was placed into orbit, January 8th, by United Launch Alliance's Vulcan rocket on its debut flight. The failure of Astrobotic's Peregrine lander, which also carried NASA payloads to the moon.
Status check. Go Vulcan.
Go Centaur.
Go Peregrine. 15. 10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. and liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
Smart Lander for Investigating Moon, Japan, JAXA launched the Smart Lander for Investigating Moon, SLIM, mission on the 6th of September 2023 at 23:42 Coordinated Universal Time, the 7th of September 8:42 Japan Standard Time. It landed on the 19th of January 2024 at 15:20 Coordinated Universal Time, making Japan the 5th country to soft land on the Moon. 98. Solar panel orientation issues and possible landing damage complicated the spacecraft's operation. The mission also deployed 2 rovers, which operated successfully and independently communicated with Earth.
Now it's looking for the safe place to land.
Intuitive Machines won Odysseus Lander, US, on the 22nd of February 2024. Intuitive Machines Odysseus successfully landed on the Moon after taking off on a SpaceX Falcon 9 liftoff on the 15th of February 2024 in a mission between NASA, SpaceX, and Intuitive Machines, marking the United States' first soft unmanned moon landing in over 50 years. This mission also marks the first privately owned spacecraft to land on the Moon and the first landing with cryogenic propellants. Though it landed successfully, one of the lander's legs broke upon landing and it tilted up on the other side, 18 degrees, due to landing on a slope.
On the 8th day of a 250,000-mile voyage, a voyage along the Great Cosmic Bridge from the launch pad at the Kennedy Space Center to the target of the south pole of the Moon, a commercial lander named Odysseus, powered by a company called Intuitive Machines, launched upon a SpaceX rocket carrying a bounty of NASA scientific instruments and bearing the dream of a new adventure in science, innovation, and American leadership in space. Well, all of that aced the landing of a lifetime. Today, for the first time in more than a half century, the U.S. has returned to the Moon.